All right, in part B, we are trying to graph f of x is equal to log base 2 of x plus 3, okay? Well, in part A, we graphed log base 2 of x, okay? So that's the blue graph, okay? So basically, if you kind of compare the two formulas here, we've got log base 2 of x, and now we're trying to go to log base 2 of x plus 3, okay? All that's changed in terms of the formula is that we've replaced x with x plus 3, okay? So you've got x plus 3 inside parentheses, okay? Anytime you add inside parentheses, that indicates a horizontal shift. So since we're adding, that means we're moving to the left, okay? So to get this function, all you need to do is shift the graph of log base 2 of x. That's kind of our parent function here. So we're going to take the graph of log base 2 of x. We're going to shift it 3 units left. Okay, that's it. And we'll end up with the graph of log base 2 of x plus 3. Okay, so let's go do that. Okay, let's go back up here. Remember, the black graph is 2 to the x. That's an exponential function. We need to shift the logarithm, which is log base 2 of x. That's the dark blue graph. Okay, I'm going to shift it 3 units left. Okay, we're going to start with the asymptote. Remember when we did exponential functions, I told you to always start with the asymptote and move that. Okay, we are shifting this dark blue graph. Remember, it has a vertical asymptote along the y-axis. Okay, so I'm going to kind of draw one in here just to emphasize that log base 2 of x has a vertical asymptote located along the y-axis. Okay, if the whole graph moves, okay, that means that the asymptote will move as well. So we're going to start by moving the asymptote 3 units left. Okay, so it will go from here to 1, 2, 3. It will be, let me get a darker color here. That's going to be right here. Okay, so this is where the asymptote is going. Okay, and now we can move specific points. Okay, so let's get started. Okay, the point that was at 1, 0, it's going to move 1, 2, 3 places left. So it's going to end up at negative 2, 0. And then the point that was at 2, 1 is going to go 1, 2, 3 places to the left. So it's going to end up at negative 1, 1. The point that was at 4, 2 is going to go 1, 2, 3 places left. So it's going to end up at 1, 2. And then this point out here at 8, 3 is going to go 1, 2, 3 units left. It's going to end up at 5, 3. Okay. You have this little point right here that is at 0.5, negative 1. Move it 1, 2, 3 places left. So it's going to end up close to the vertical asymptote. Okay. You're going to connect the dots with the same basic shape. Okay. So logarithm, one side's going to climb very slowly. The other side's going to level off at the vertical asymptote. Okay, so this is the graph of log base 2 of x plus 3. We just shifted the dark blue graph 3 units to the left. Okay, all right, now we're going to go to the bottom and we're going to write down the attributes of this graph. Okay, so what about the domain? Okay, the domain has definitely changed, okay, because the whole graph shifted horizontally. Okay, so where does your graph start? Okay, well, the vertical asymptote goes through x equals negative 3. Okay, we don't cross or touch that vertical asymptote. Okay, the graph starts just on the other side of x equals negative 3. So what we're going to say is essentially your graph does start at x equals negative 3. That's going to be the leftmost x value, but we're not going to include it because we do not cross or touch that asymptote. Okay? If we find our rightmost point on the light blue graph, remember it's going to go, if you follow my cursor here, it's going to go this way forever. Okay, so the rightmost point is going to be positive infinity. Okay, so your domain here, the x values you can plug in are all real numbers bigger than, strictly bigger than -3. All right, let's look at the range. Okay, we want to go from the lowest point to the highest point. Okay, the graph goes down, 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 down forever. So the lowest y value is going to be -infinity. And then this logarithmic graph behaves like other logarithms. It is climbing this way, just ultra slowly. Eventually, it'll get to a y value of +infinity, but it's going to take forever. Okay, the domain, or range. Range of a logarithmic function is always, always, always all real numbers. Okay, all right. The x-intercept, did it move? Okay, well, yes. Light blue graph is crossing the x-axis right here at -2. Okay, so we're going to write that our x-intercept is x equals -2 as an ordered pair. That's -2, 0. Okay, the vertical asymptote has definitely changed. It's the light blue dotted line. Okay, it is going through the point x equals -3. Okay, remember vertical lines, you write them as x equals. Okay, you have to give an asymptote as an equation. Okay, so it is the line x equals -3. Every point on this dotted light blue line has an x value of -3. Okay, so we have graphed log base 2 of x plus 3 in light blue and written down its attributes. Okay, moving on to the top of page 5, we are going to try to graph f of x is equal to log base 2 of x plus 3 minus 1. Okay, again, we do not have to start from scratch. This graph also involves log base 2. In fact, it involves the graph we just did in light blue. Okay, it involves log base 2 of x plus 3. That's the graph that we just did in part B. Okay, log base 2 of x plus 3. What's different is that now we're subtracting 1. Okay, so this is just going to involve another transformation, this time of the light blue graph. Okay, because again, this part that I'm highlighting, that's the light blue graph. Okay, all we have to do now is factor in this -1, where we're subtracting 1 outside of parentheses. Okay, all right. So think about transformation rules. If you're subtracting a number outside of parentheses, that's a vertical shift. And since you're subtracting, you're going to go down. So all we have to do here is take the light blue graph, which is the graph of log base 2 of x plus 3, and we need to shift it down 1 unit. That's all we have to do. Okay, take the light blue graph, not the dark blue graph, shift it down 1 unit. Okay, so let's go do it. Okay, I'm going to put it in orange. Okay, all right. If I want to start with the asymptote. Okay, so imagine shifting this light blue asymptote down 1 unit. That's not going to change the asymptote. Okay, so this new graph that we're constructing, I'm putting it in orange. It's going to have the same asymptote as the light blue graph. Okay, now we need to take each point on the light blue graph and go down 1 unit. Okay, so just take your points, shift them down. That's all you got to do. Okay, connect the dots with the same basic shape. Okay, so one side will climb very slowly. The other side will level off. Oops, that wasn't very good. It will level off at the vertical asymptote here. Okay, so this orange one is the graph of log base 2 of x plus 3 minus 1. Okay, so we just took the light blue graph, shifted the whole thing down 1 unit. Okay, for the attributes here, okay, what's the domain? Okay, well, the domain has not changed. Okay, the orange graph essentially starts at its vertical asymptote, which is x equals -3. Okay, that's like the leftmost point on the graph. So we're going to go ahead and say the graph essentially starts at -3. We don't cross or touch that vertical asymptote, so we're going to exclude -3. Okay, but the rightmost point on the graph is if you follow the graph, the rightmost point is going to be positive infinity. Okay, so the domain here is the same as log base 2 of x plus 3. The domain is all real numbers bigger than, strictly bigger than negative 3. Okay, so you can plug any x value into this function that's bigger than negative 3. Okay, range, this is a logarithmic function, so the range will automatically be all real numbers. Okay, your lowest point on the graph, your lowest point's going down, down, down forever. Your highest point, it's climbing very slowly, but eventually it will get to positive infinity. Okay, what about the x-intercept? Okay, that did change. Okay, we shifted down 1 unit, so now we're crossing the x-axis at the point -1, 0. That's right here, if you can see where my cursor is. Okay, so the x-intercept is x equals -1, or you can write it as an ordered pair -1, 0. Okay, lastly, we know the vertical asymptote is the same as it was for the light blue graph. So the vertical asymptote is going to be x equals -3. Okay, you can see the orange dotted line, that's the same as the light blue dotted line. Every point on that dotted line has an x coordinate of -3. Okay, so here we go. Asymptote has to be written as an equation. Okay, its equation here is x equals -3.